All right, the next thing we want to do is work on multiplying radicals. So we're going to work our way up through some operations. And interestingly, addition and subtraction tend to be the ones that give the most trouble. So we'll start with multiplying and dividing, and then we'll work up to addition and subtraction from there. The thing to think about with multiplication, the first step's really easy, but remember that you will need to simplify. So every multiplication problem will also include some simplification. So first one, I think, isn't anything too crazy at all. Just remember we have a multiplication property for radicals. Root A times root B is the same as root A times B, and it can be helpful in both directions. For simplification, we started with the root of AB and split it up. To multiply two radicals together, you're going to combine them, but interestingly, sometimes your next step will be to split things back up, maybe in a different way. So root 5 times root 6, it might be good to take a quick check and just see if there's anything you can take the square root of right away. Otherwise, we're going to combine that into a single root, so we get the square root of 5 times 6, which is 30. And then you just want to look at that and see if you have combined and ended up with any perfect squares as factors that you could subtract out. For 30, I don't think I'm seeing any, so we'll double check. 3 times 10. And then that could become 3 times 5 times 2. So I don't have any repeated factors, which means that's already simplified and I'm done. So let's just try another one. We'll work our way up and I think we'll start seeing some simplify. So I have square root of 3 times square root of 6. I still don't see anything I can do with those roots separately, so I'll go ahead and combine them first. But maybe you can even see it in there. If I have a 3 under the first root and a 2 times 3 under the second root, when I combine them, I will have a repeated factor. So now I can look at this 18, and I'm going to start doing it a little bit more shorthand. I can see with 18 that I have a factor of 9 that's a perfect square. So I will separate that back out. So 18 is 9 times 2, and I can split it into root 9 times root 2. And then I can take the square root of 9, and that simplifies it for me. So often you will be able to do at least a little bit of simplification. Okay, just to make sure this doesn't throw you off, you might have a number already sitting out in front of your square root, and that doesn't change the process really. It just means you want to make sure you don't lose that number sitting out in front. So if I look at the square root of 8 times the square root of 6, you could actually extract out a factor of 4 from the 8. But if it's not a perfect square, I generally just combine them first so that I don't do multiple steps of extracting roots. So the 2 will just sit out in front. The square root of 8 times the square root of 6 becomes the square root of 8 times 6, which is 48. And then I'm hoping to spot factors of 48 that are perfect squares. I think that one's maybe slightly trickier than the last one. I think I could probably get a 16 out of it, but we can work our way up to that. So 48 is 2 times 24, and 24 is 2 times 12, and 12 is 2 times 6, and 6, 1, 2, 3, 4, is 2 times 3. So I actually get 2 pairs out of that. I get a pair of 2 and then another pair of 2s. So I'm going to end up with the single 2 sitting out in front that was already there. That's the thing you don't want to lose track of, and it just continues to be multiplied. And then when I take the square root of the first pair, I get a single 2. And when I take the square root of the next pair, I get a single 2. And when I take the square root of 3, it doesn't clean up at all, so I just write that down. And I get 8 root 3. So that one simplified fairly well. And again, you could have extracted right from this first step, and you would just have to then extract again once you combine the roots. But I prefer to just do it all at once. So I usually save it up and do all that factoring out in one big ugly step. Okay, so again, let's get some variables in the mix. So square root of 2x times the square root of 6x cubed. I don't see a real easy perfect square just sitting there, so I'm going to combine them first. I can multiply the 6 and the 2 together to get 12. And I can multiply the x and the x cubed together to get x to the 4th. And then I'm looking for factors that are perfect squares. 12 is 4 times 3. So I could definitely split off a 4. The 3 is going to be a leftover. X to the 4th is a perfect square. So I'm going to separate off a square root of 4 and a square root of x to the 4th, and I will have a leftover square root of 3 that I know I won't be able to simplify. The square root of 4 is 2. Remember, if you're getting stuck on that x to the 4th, you have to think a little bit differently. That's x to the 4th raised to the 1/2. So that ends up becoming x squared. You would multiply those two exponents. And then again, that root 3 is just the extra bit that you can't simplify, so you'll just leave it there. So get as much out from under that square root as possible. All right, let's look at another one where we actually have things out in front of the square root already. So remember that multiplication can happen in any order, so I'm actually going to regroup a little bit. And you don't have to write this step out, but I just want to make sure everybody sees what I'm doing. I'm just rearranging and saying I can multiply the negative 2x by the 5x squared, and I can multiply the root 3x by the root 12x to the 9. And order doesn't matter in multiplication, so you can write it with those things grouped together. The 2 times 5 is negative 10, and x times x squared is x cubed. So I'm just going to leave that alone. I will combine the roots. I get a 3 times 12, which is a 36, and x times x to the 9, so that's x to the 1 times x to the 9, which becomes x to the 10. You add exponents there. So now I want to try to extract from under the square root, and actually this time everything under there is a perfect square. So if you want to, you can split them up. This is up to you if that makes it look simpler or not to you. But I can do both of those roots without splitting anything up. The square root of 36 is 6, and the square root of x to the 10 is x to the 5th. Remember, that's x to the 10 to the 1/2, which becomes x to the 5th. So really all I need to do is one last regrouping. I can multiply the negative 10 and the 6 to get negative 60, and the x cubed times x to the 5th, we add those powers and get x to the 8. So that one was fairly messy, but if we take it carefully, we should be able to get through. I have just one more that's actually kind of similar. It looks a little ugly with the fractions, but I just wanted to do one more of those messy ones, really. So let's go for it. I can regroup a little again and say, okay, I'm going to group that x over 2 and that 4 together, and then I'm going to group the 11x to the 5th with the 22x to the 8. And again, if you can do that grouping in your head, go for it. You don't have to write this step. One thing I'm seeing that I like, we can write that 4 over 1 if that helps you get things lined up, is that I can cancel a 2 out. So that x over 2 times 4 actually ends up just being a 2 times x times 2, which we usually would write as 2 times x. When I combine the roots, I am noticing something just as kind of a anticipation. That 22 is 11 times 2, so when I multiply that by another 11, I am expecting to get an 11 squared. So just to help a little with that factorization. But 11 times 22 should give us 242, and then x to the 5th times x to the 8th gives us x to the 13. We have to add exponents there. So when I split that 242 up, I can already see the factors from what I did up above. In fact, you don't even have to multiply it in. You could just start breaking it up if you prefer. I know I can get an 11 squared out of that. For the x to the 13, I can split off 12 x's, but I will have a single one left over that I can't extract. So I'm seeing a 2x root 121, or 11 times 11, however you want to write that. And I'll have a root x to the 12, and then I'll be left with a root 2 and a root x, which I'll go ahead and combine because I know I can't simplify those anymore. And when I go for it, square root of 121 is 11. Square root of x to the 12 is x to the 6th. Again, thinking x to the 12 to the 1/2. So you're going to have to really think about when you're actually square rooting a number versus when you're dividing a power by 2, and try to not get those mixed up. Before we start mushing them all together in this work, that's usually pretty easy to keep track of, but once we start combining them, it can get a little bit confusing for a while. Okay, so final answer, I see a 22, I see an x to the 7, and then left under the square root is that 2x, and I don't think I can do any better, so we'll leave it just like that.